Hello. Oops. I'm back with more math proofs. Today I'm gonna go about doing proof 5, which is essentially the proof for linear change of variables. Um, so what this proof says is that if there is a transformation d which goes from R of n to R of n, and this t is an invertible linear transformation, and there's some function f which goes from R of n to R, and this function is integrable, we gotta prove that f composed with t is also integrable, and that integral R of n f y dn y is equal to determinant of t R of n f of t x d of n x. All right. Okay. So in the parameter space of this function, or rather this, we consider a dyadic partition dn, which is made up of a bunch of like little cubes. So there's some dyadic partition dn, and this consists of n number of c cubes, and these are just like little bits that we want to break up that partition into, and the t that we have maps them to n parallelograms. So what this says is, I'm going to sketch this out because it's a bit easier to understand. And this thing maps it to some like these little parallelograms. And so in this sort of little cartoon picture, it's going to be dfn. This is t of d of n. This would be c. This would be t of c, for example. And the integral in this case is a Riemann sum of the the integral is a limit of the upper Riemann sums in parameter space. So we're essentially going to start with this side of the equation in this case, which is start off with R of n, f of dx, and then determinant of t, d of n, x bar is equal to, I'm gonna go about expanding this, the limit of n is equal to infinity, upper sum as we said, f composed with t, d of n, and that times the determinant of t, which is equal to limit n tends to infinity, sum over c n, sorry, it's actually dn, f composed with t, det t, whoops, I'm gonna swoosh all of this stuff over. T vol n c, which is equal to lim n tends to infinity sigma c to the power of dn m c f o f composed with t volume of n t c and then MC. So now we want to sort of go back and expand out this bit. This is the general strategy. Now we know from the last module that we did show that T volume stretches any n cube by determinant of T, which we kind of know that it sort of changes size. So in a way we can write down volume of nt of c is equal to determinant of t volume of n c. Now we're gonna express the supremum in the above a little differently, so c f composed with t, which is what we're doing now, so the strategy of substituting, so supremum of f of t of x bar the part of c, which is an element in c. This thing sort of becomes supremum of f d x d of x into d of c, which is equal to supremum of f y element of d of c, which is equal to empty c f. Then we're going to sort of put all of these things back together where we started. So going back to our first set of inequalities, I'm going to copy this guy. Alright, so we're going to substitute in values. So this becomes limit of n tends to infinity summation of c of element dn empty c f of volume of n dc, which is equal to limit n tends to infinity d of c d of dn m d of c f volume of n dc, which is equal to limit infinity u f d of n, which is equal to r of n f of y bar dn y bar, Alright, which is kind of what we wanted to show back here. Yeah,